Hello and welcome to the A-Level Physics channel. My name's Remik and I'll be teaching you A-Level Physics. Today we're dealing with SI units, the prefixes, and estimating physical quantities. There is a seemingly endless list of units used in physics, but all of these units can actually be boiled down to 6 base SI units. SI stands for International Standard. It's the units used all around the world to avoid confusion between measurements in collaborative projects where language may be a barrier. The 6 base units used are mass in kilograms, length in meters, time in seconds, current in amps, temperature is in Kelvin, not Celsius, and amount of substance is in moles. It might sound mad that every single unit in the world comes from those 6, but it's true. An example is the best way to explain this. If you take the unit of force, the Newton, named after the main man himself, Isaac Newton, and look at his famous equation, F equals ma, which is the definition of force, you'll see exactly how it works. Force is measured in newtons, so we write the Newton below the letter F. Mass is in kilograms, so let's put the kg there, and acceleration is in meters per second squared. So, just as force equals mass times acceleration, the Newton equals kilograms times meters per second squared. As you can see, the Newton is the derived unit equivalent to the units kilogram meters per second squared. All units, like the Newton, such as joules, volts, and the rest, are known as derived units, and all derived units are from the 6 base SI units. This may be slightly difficult to wrap your head around at first, but as you go on through the course, it's really not that difficult. You'll come across it in every single topic you do. By the time your exams actually come around, it'll be second nature. So, powers of 10. The physics A-level is very broad in its content. We look at the physics of quite literally the smallest and largest entities in the universe. 1 week we're dealing with the distance between atoms, the next we're dealing with the radius of the whole galaxy, or maybe even the observable universe itself. If we want to measure things in common units, which we do, to make sense of its true size, and of course to use these measurements in equations, there's lots of zeros involved. Whether that's before a decimal point for the size of a galaxy as such, or after it for the size of a nucleus. What we do to make this more manageable is use prefixes before the physical quantity in question. For example, if you put kilo, K, in front of meters, it's 1,000 meters, or a kilometer, as kilo is 10 to the power of 3. It doesn't get any more complicated, only the power of 10 becomes smaller or bigger with different prefixes, but it's the same concept. To make life more straightforward, we use a set of prefixes and associated symbols to represent these powers of 10. This table shows all of them. Using this table, if you had, say, a force of 10,000 newtons, you could just write it as 10 kilonewtons or 10 kN. In exam questions, these symbols and prefixes are used interchangeably, so you'll need to get comfortable with them, but the more questions you do, the more topics you cover, you'll be completely fine with it. Next up on the agenda is the concept of estimating physical quantities and orders of magnitude. First, let's deal with what the phrase order of magnitude actually means. Simply, it's a power of 10. A quantity is an order of magnitude larger than another if it is 10 times or about 10 times larger. Just as something 100 times bigger is 2 orders of magnitude larger, and 1,000 times bigger is 3 orders of magnitudes larger. In the exam, if you're asked to give the value of an order of magnitude, it would be as follows. Let's say they've asked for the order of magnitude of the radius of the sun, which is this value. We will note that value down due to the number of zeros in standard form. The order of magnitude of any number is the 10 to the power of something part of the number. So in this case, the order of magnitude is 10 to the power of 8. When it comes to estimating physical quantities, there's no formula to it. It's more sort of a ballpark guess. In the exam, you'll get a massive range of values which are accepted as long as they're reasonable. A few good ones are a car weighs about 1,500 kilograms, a human's about 2 meters tall, an atom is about 1 times 10 to the minus 10 meters across. Again, there's no real hard set rules. It's just a general thing that you'll have to get good at, but you'll come with time, come with practice. Well, that just about does it with your introduction to A-level physics. Nothing too groundbreaking or earth-shattering. Remember, the website has all of these videos indexed more neatly for every subject that we deal with, exam question packs, walkthroughs, and advice on getting into uni. So, thank you for watching. Enjoy the next video.